workshop continues now with the natural workflow we have in OMERO, and this is after we viewed the after we imported the images, we want to view them. Okay, because what we saw up till now was just preview, and we manipulated the rendering settings. In next step, we go to the siRNA HeLa dataset, just as I'm doing on the left-hand side inside OMERO.web, and I will select an image, which is let's say with multiple Z sections, just to be more adventurous. Let's go for the Scrum 06R3D. And I can either use the full viewer button on the top right, on the top left of the general pane, or on the right hand pane, or I can simply double click on that thumbnail. So if I do so, then a new tab in my Firefox opens, and I have here a view of a viewer called OMERO.iViewer. It's an extension of OMERO.web. I have first of all a column of the thumbnails on the left-hand side, which shows all the other images, representation of all the other images from the data set. My image being the one which I selected in the first place. The viewer is able to view the Z stacks as we see here on the slider, which I'm just moving and going through the Z planes. Can also make projections. If that would be a time lapse, which it is not in this case, I would have here a slider on the bottom going through the time dimension. You know these settings, they are nothing else but the repetition of what we studied in the preview pane. And we have here also a ROIs tab. Okay, I will first of all delete all the ROIs which I have here already, so as not to confuse you. This is done by selecting all of them and then clicking save just to confirm the deletion. And I will refresh the page and navigate to the ROIs tab again. And now I'm on a clean slate. On the plate number 21 out of 40, I can now select a shape here and start drawing a new region of interest, such as a rectangle. Now, that is something to dwell on for a second. How to draw regions of interest in OMERO.iViewer. It's a little bit different pattern than what you might be used from ImageJ. You click, then you let go. You can see that my finger is not in use here. I will just move my mouse like so. My finger is still not in use. I just click once more. That's where I used it, and that's my rectangle drawn. Okay. In contrast to that, if I drag as I would normally, I click and drag, I will move the whole image. Okay, that's not what you want. I will delete the other ROI which I drawn by accident, and I can see here that in the table I have the Z-plane association with the of that ROI. I have here some comments on that ROI as well. The basic data from the rudimentary image analysis I can do inside the OMERO, inside OMERO.iViewer are highlighted here. And I can associate and disassociate the ROI from the Z-plane. Let's do it later. I can go to another Z-plane. You can see that the ROI vanished because it's only on Z-plane 21. I am now on Z-plane 28 and draw another ROI, let's say a polyline. And for that, I can now hold with my left hand the shift button on the keyboard. And then this time I will use that finger on the right hand to drag indeed, and this will draw a polyline like so. So this was another way how to create a ROI, and I will go to another Z-plane, number 8, and draw a polygon, which is probably very interesting. Again, hold shift on the keyboard and drag around this DNA of the cell, and this draws this polygon. So I have 3 ROIs associated to different Z-planes. Let's say I can go here and disassociate this rectangle to any Z-plane and save all of them. And now I can select all of the ROIs and go to the ROIs tab, and I say export as stable CSV. I click on that, and then I have directly an option to open that locally in Microsoft Excel, which I'm doing. And here it comes locally on my Mac, downloaded just freshly from my OMERO iViewer, is the rudimentary image analysis on those ROIs. I can see that the Z is not filled in for the rectangle because I disassociated it. I have just one T-plane. And I have, of course, the areas for the ROIs which encompass an area, whereas for the line, I have the length. I have the area in points or the length in points, meaning uncalibrated, but these images are calibrated. So I have it here in the correct units. Then some intensity values, and then very importantly, also the XY coordinates defining the whole ROI. Obviously, the freehand drawn ROIs have quite a few points to them, but all of them I have at my fingertips now here locally in my Excel. So if I go back to the OMERO iViewer, that was basically the image analysis I can do, unless I use some scripting here. But as we highlighted, we will go through some image analysis routines, which I can do using third-party software such as Fiji or other softwares. Now, having done that, let me show you a popular feature in OMERO iViewer, which is basically multi-view. If I want to see side by side the different channels in this image, I forgot one more very important thing. I have also here the channels listed, and you can see that per region of interest, I have 3 channels, but this is a 4-channel image. The answer to that mystery is that if I go to the settings, I can see that the 4th channel is not on, and only the channels which are on are contributing to the analysis table. So let me just go through with you with the multi-view. In the case I want to see the channels side by side, I don't have this popular feature in OMERO iViewer called split view. Instead, I can open another window of OMERO iViewer. Yes. Let me just quickly change the resolution of my screen because I'm struggling to the max. Yes, very nice. Close this one. Double click. Yeah, now I have much more real estate. And I can see that I can have 2 windows which I opened in double click. By double clicking, I can open a 3rd window by dragging and dropping on the white canvas. And I can now associate those windows with different channels. So for example, this one with blue, this one with green, and this one with first red. Okay. Now you can see that if I drag or zoom in one of those viewers, then the others are not in sync. I can change that by selecting the first lock icon on the top left, and this will bring the channels in sync in the sense of following parameters. I mean, in this sense, would sync the Z and T and the view. So much so that when I start scrolling, you can see that the Z and T is now synchronized because it jumps in sync, and the view as well. If I start zooming in or panning, you can see that now all those three viewers are panning and zooming in sync. Okay, I can now go ahead and compare this image in 3 channels with another image, which I can facilitate by dropping in another full viewer, or dropping another image in the existing window, like so. Okay, and or if I select a window, I can click on another image and this will pop the new image into that selected window. This is a single click. Or if I want to use a double click, then I can, and this will of course open a new viewer, fully new viewer. Okay, so double click, new viewer, single click, pop in the new image into existing window, as well as drag and drop into white pane is new window, and drag and drop into existing is of course replace the image inside the existing window. That is a very popular feature, and I think we would be done with the main characteristics of OMERO iViewer. Let's go back to the OMERO.web. I will again change the resolution of my screen because you would like to see this tree better, and that's of course paramount. Very good. That's interesting. Okay. Right, that's where I wanted to be. I would like to show you the possibilities of OMERO with respect to annotating. So for that, I'm back in the tab where I have the web client with the SRNI HeLa dataset open, and I can now go and let's say filter in the center pane. I can filter by several parameters. Let's filter by tag. These are tags which were added by my colleague Will, and they denote the mitotic phase of the cells on the particular images. So if I choose the anaphase tag, I can see that the images which are not in anaphase were filtered out. And if I select one image and drop down the tags harmonica, I can see that it has indeed the anaphase tag. And in this harmonica, I can also add or remove the tags to that particular image. I can, of course, multi-select a couple of images and do this action on all of them. I can create new tags like writing, let's say, new for GBI, hit enter, and then it would be added there. Okay, I will reset and cancel. You feel free to add new tags, but maybe please, if you could delete them later. In this manner, I can organize my images as just highlighted, so much so that when I then remove the anaphase, I can go to metaphase and so on, and have kind of the overview of the mitotic phases, obviously. Some of those images have then other tagging or annotating possibilities, such as rating, where I can rate the images by stars. And I can see that what we've done here with Will is we've added some ratings to images from each mitotic phase. So this is an anaphase which we liked the most, metaphase which we liked the most, and this is a representative of prometaphase which we liked the most. This would be like kind of a prep if you want to start to show and kind of publish your results to outer world or your peers or the leader of the group, and we will use that later. So this was done the second possibility of annotation, which is ratings. Nevertheless, if I click the filters here and go back to one single image, you can see that we have here a annotation possibility, which is possibly the most important and popular of all the possibilities in OMERO, and this is key value pairs. Key value pair is basically a small table of keys and values which resemble very strongly the lab book of a typical wet lab scientist. So if you think about how you construct your notes when you are doing an experiment, you would go not just single item of information such as anaphase, you would go rather solvent was methanol, secondary antibody was antigote, concentration of secondary antibody was 1 to 1000. Primary antibody was anti-actin or whatever. Okay, so this is always a temperature was 37. This is always something which we call key, meaning a category of quality such as temperature or secondary antibody concentration, and then the value which is just denoting the number, the height of this quality. With this type of keys and values, you can capture a lot of information in a sensible manner, which you would not be able to do with tags because you would not understand which tag belongs to which. And we are using them also in the IDR. And this is a foretaste of tomorrow's workshops where we can organize the key value pairs in this very nice stable manner in the groupings, etc. But if you want to be on a basic level, you can add the key value pairs manually by clicking this plus and simply type in, let's say, secondary AB and then GOAT. Okay, in this manner, these key value pairs are then searchable. If I, let's say, okay, pardon me, sorry about that. And this was, if I, let's say, search for secondary in the top bar, this is the main search of OMERO. I hit enter and I can see that I found one image, but this is not what I wanted. If I want to search, let's say, for mitomycin A, okay, it will spit out a lot of results. It will basically give me any results which have anywhere in the name or otherwise the term mitomycin A. But if I want to be more specific and go for key value pairs, I can go mitomycin A 0 millimolar with a colon in between. Colon denotes that it must be a key value pair. And I can go and find some image, which is obviously from the siRNA HeLa dataset. And I can see that indeed it has a key mitomycin A and a value 0 millimolar. Once found an image like that, I can go back and find where it's located by clicking on this browse button. The search, of course, has more possibilities, which I don't want to go into right now, but hopefully you can see the power of the key value pairs. We have the flexible structures called OMERO tables, which have some data in them, as highlighted right now. And these tables can be imported using a command line from, let's say, CSV, comma-separated value type of files, which you can easily create from Microsoft Excel files. Furthermore, the the attachments give you ability to attach any files to a object in OMERO, object being image dataset project or screen well played. You can attach them from a local hierarchy, such as so. I can, for example, add this GPI real macro IJM file, which is an image.j macro file. I will open it and then attach it to this image. This does not mean that OMERO suddenly got an ability to interpret image.j macros. It doesn't. But what I can use this kind of, let's say, store and sensibly link facility of the OMERO server for is to go back to this image.j macro file later and let's say even automatically harvest this recipe, let's say, and run some image analysis on the particular image or many of them. Or indeed add some description files in the form of PDFs and CSVs. PDFs and CSVs will be then indexed by the big search I just shown. And in this manner, you can again hasten the overview of the images. Indeed, you can attach here whatever you like, but as I said, except for the searching in PDFs and text files, you will not be able to ask OMERO for interpreting some complex file formats such as Excel sheets or some such, except for when you, of course, download them and or enable access to them via OMERO API, which is a very good possibility. You can add comments as well to images, etc. Very good. So this leaves me with some time to start on this would be the annotations, which we just went through, a very important part. And now let's go mentally further in the workflow of a typical scientist. I have imported the images. I made some general first overview of them. I viewed them. I drawn manually some regions of interest, done some rudimentary analysis, let's say a pilot rudimentary analysis. Then I want to seriously analyze them using some more powerful analysis software such as Fiji. Let's do that. I start my Fiji. Okay. I have installed previously into my Fiji a OMERO plugin for Fiji, which is easily downloaded from the website from which you grabbed the OMERO.insight if you bothered to install OMERO.insight, and then added this file. It's a single jar to my plugins folder of my Fiji. And now I'm just basically starting the Fiji, and under the plugins menu of my Fiji is a new item called OMERO, and I click on Connect to OMERO. It offers me the workshop pre-populated, so I can just put in my password and click login, and this will be my Fiji connected to OMERO server. Now, this looks so suspiciously similar to OMERO.insight, okay? But please don't get confused. What we are here in, that application locally is called Fiji. So the client, the local application or the client of OMERO is called Fiji, okay? Fiji just has a plugin which has the same code as OMERO.insight. That's why it looks the same, but it's not OMERO.insight, okay? It's something different which strictly runs under the command of the application called Fiji. And this Fiji is able now to go to the OMERO server and grab an image. And if I double click on this image, let's say from a Fiji dataset, then it will pop up a bioformats window. You already know by now that the bioformats is the Java library, which gets shipped with every Fiji and which is developed by us. And we can now use that to open a proprietary file format, in this case a DV. And I click OK, and the image has been fetched from the OMERO server in its entirety into the working memory of my computer, and it's free to my peruse in the application called Fiji. Okay, so this is an image in Fiji now, so easily grabbed and fetched from OMERO, and I can do every magic I can do in Fiji on that image. So much so that, for example, if I draw a freehand region, which will be a very silly one, so that we can easily recognize that freehand region in OMERO later, such as this one, and then hit T in order to add this freehand region into ROI Manager, and then run some measurements on that so that I have a table result from Fiji, like so. Now I can go and say in the main menu under plugins, OMERO, save ROIs to OMERO, and this will pop up a new dialog. I will say that I want measurements as well. Let's say GBI 2022 measure, and then say save. Okay, the results were saved as quickly as that, and now I can go back to OMERO.web, navigate to my dataset, a Fiji dataset, and if I click here, you can see that the ROI count is 1. I can open the iViewer by, now, by double clicking on the thumbnail, and this opens the image in OMERO iViewer. And now I can go and in the ROIs tab indeed see that the ROI was translated from a Fiji type ROI into an OMERO form of that ROI. And this OMERO ROI was saved on the same image in OMERO with just one click. So this is how I use the ability of Fiji to quickly draw a ROI. And as well as I can go now here to the right-hand pane, and I have plenty of results and attachments from previous workshops indeed. But what I am after is the GBI 2022 measure CSV, which is the one I just saved today. It's also written in the tooltip, helpfully. It's 25th of January. And I can now open that measurement file in my local Excel. This is indeed one-liner because I quickly created it in Fiji, but you can of course see the superior power of Fiji as compared to the OMERO iViewer, which I can now harvest very easily by using this OMERO plugin for Fiji, which gives me parameters like ferret X, ferret Y, ferret angle, and so on, perimeter, etc., etc. If I want to go a little bit deeper, I would like to, let's say, create a new image from an existing image. So I close this image and I reopen it again. So again, this comes from, by the way, you just saw that the region of interest from OMERO opened also in Fiji. So I can go full circle. I can basically draw a ROI in OMERO and open it in Fiji, or draw a ROI in Fiji, save it to OMERO and reopen it in Fiji as I see fit. If I want to create a new image, this is also a typical task during image analysis. The easiest way is to do that via cropping. So I can draw a rectangular ROI, go image, crop, and this is my crop. Now I can go into plugins, OMERO, and save images to OMERO. Yes, that's fine. That's just a security on my Mac. And I can now yes, I can now, let's say, select dataset, the same dataset from which the image came, called a Fiji dataset. I will add the image to queue. Like so. You can see now it's in the queue here. Pardon me. And I click import. And ignoring this very chatty console, I can see that I have my 2 blue bars and the import was successful. And if I quickly go to OMERO.web, I can see that in this dataset there are 4 images. If I click refresh, suddenly there is a 5th image, which is of course the crop I just created in ImageJ. Very good. So just to let's say give a motivation for the later work on OMERO Parade and OMERO.figure, I will do some more sensible analysis. Let's say, let me reopen the same image again, and this time, doing something more fancy. So I will simply segment the centrioles inside that image by first thresholding the image. Like so. Okay. This is a thresholded image. You can see that this is now consisting of either 252 or 0 values. And I can now run a analyze particle plugin on such image. I think, okay. Process all 3 images. Don't save the measurements. Okay. Okay, so that's fine. There was a small mistake. I will just go again. Because I had selected a wrong parameter I selected the wrong parameter when thresholding, then the follow-up plugin detected the ROI wrongly. It was just a ROI over the whole image. So if I auto threshold and then click out this and then go max entropy, maybe this will work. Analyze particles. Okay. Yes. Great. Okay. I have here now the ROIs which look much more benign. You can see that they are around the centrioles in Fiji, and I can now again go and save the ROIs to OMERO like so. Okay. Together, let's say with measurements, serious GBI, and save them. Okay, I have the option to put the ROIs on the new image or on the original image. That's fine. So if I click, I can see here that I have 13 regions of interest, and I can see those. And this is a funny ROI which are drawn manually, but these are the ROIs which I just did from the serious segmentation. You can see they make sense. They do make sense. They are really around the objects, around the centrioles. This is real serious segmentation. and they are coming from Fiji. Okay, so remember that for me, because we will come back to that. We just did it manually with you as a demo. We ran this analysis. I just kind of highlighted for you on the whole project with 414 images. You can see I have here images like that with centrioles in them in this project, and we then put the results into a summary table, which is an OMERO table. This is this flexible structure, Python-based structure for storing of analysis results, as well as for CSV, and we will explore that just after the break.
Peter, can I just interject? Because there were a few questions in the chat of the behavior of the plugin. So most of the time, the way Fiji works, when you analyze your analysis in Fiji, you will get the full data, depending of the option you use from bioformat, the full data being transferred locally, analyzed and discarded, and so on and so forth. So in the case of Alex, the analysis is not done in the server side, it will be done where Fiji lives. So if Fiji lives on your PC, that's where the analysis will be done, and the result will be then transferred back to the server. There's another approach, and I put a link into the chat of where images can be big. You can actually, there are mechanisms, and we have example of that, where you can actually fetch only the plane you want to analyze or render. So if you know that you want only the first channel and first time point and first Z section, you don't need to download everything. So the API allow you to do that and analyze only those planes. So there are various mechanisms. Unfortunately, if you do the the plane-based approach, as I was describing, you need to build an ImageJ object in order for ImageJ to understand it. To do analysis of ImageJ server side, it's possible, but it's a bit more involved, and I would say it's not recommended, in the sense that Fiji is not going to, if you have concurrent user trying to do analyze in Fiji at the same time, they will enter into trouble, because it's not built for this type of setup. Over from me, Peter.
Okay, thank you. If there are no more questions, yeah, maybe we could exactly. So let's just show this. These are scripts which you can run in several environments. The suggestion could be the scripting dialog of Fiji, like so, file, new script, and then you would grab the script which does this and that, really a lot of stuff, not only what just mentioned by Jean-Marie. Of course, he was talking about how to simply open the image in Fiji, but he prepared quite an awesome portfolio of scripts by now, which does a lot of stuff, such as, for example, even the cropping, and which of course serve as a template to give you an inspiration what you could be doing. The other option is to run the binder and create a small machine on the cloud, which we also provide as an option here. And you can see that you have here in the user guide for Fiji, or in this GitHub page, a launcher badge where I can click on that. I will not go through the whole thing. I just want to demonstrate what it does. It will open a new tab, and here a binder, which is basically a free cloud-based service, will, according to the recipe which Jean-Marie prepared, build for us a Docker, basically kind of like a small machine on the cloud, which will contain all the dependencies, obviously a full running Fiji and the dependencies which are necessary to connect Fiji to OMERO, as well as a desktop environment, a rudimentary desktop environment. And all the scripts which are listed here, right here, for example, they will be simply automatically included. Oh, it's actually already here. And will be included there, okay? Such as this one. So it depends on how busy the, so to say, the cloud and the service is. But you can create a desktop like so. Note that I am now in my browser. Okay, so I didn't jump into the local environment, use default config, and I can now, let's say, create a new, it said, new terminal, and inside the terminal there will be, if I do cd scripts, okay, NLS, you can see cd groovy, ls. So all the scripts are here suddenly. These are on the cloud, and I can now go and start them and say, okay, start this and that script, and Fiji, which is hidden inside the Docker on the cloud as well, will start doing magic, fetching images, segmenting them, and so you are very much welcome to do that. For you, the most natural way to approach that is, let me go back to OMERO guides, to, let's say, or even to our walkthrough, pardon me, GBI 2022 OMERO workshop. If you go to analysis with Fiji, which is a section in our walkthrough, you can see for the setup of a Fiji plugin, see this, and you can open the link in a new tab and click on this one, on this link to Fiji, and then go, and here you have the launch binder batch. Okay, so that's how we would get, obviously, very quickly to this environment, just as easily as I did. You saw I didn't do anything particularly horrific. I just clicked on a couple of buttons and it built up the whole environment for me.